sum of squared errors or residuals, abbreviated SSE. The equations with the smallest sum of squared errors or residuals is considered to be the best fitting equation. Here's an example. Data was collected on height and weight. First person had height 60 inches, weight 150 pounds. Second person had height 70 inches, weight 130 pounds. Third person had height 80 inches and weight 200 pounds. So we want to find a linear equation for predicting the weight based on the height. DIVA thinks the best fitting linear equation for weight based on height, y hat is equal to 2x plus 30. The best fitting equation should have the smallest sum of squared errors. So let's compute the sum of squared errors for DIVA's equation to see how good it is. For the first person, height was 60 inches, so the predicted weight according to DIVA would be 2 times 60 plus 30, which is equal to 150. So the squared residual, the squared error, 150 minus 150 is 0. 0 squared is 0. The second person had height 70, so according to DIVA's equation, the predicted weight 2 times 70 plus 30 comes out to be 170, and then the squared residual is the actual minus the predicted. 130 was the actual weight minus 170, negative 40, squared that is 1600. Okay, so the third person height was 80, so the predicted would be 2 times 80 plus 30. 2 times 80 is 160, plus 30 is 190. So then the squared residual, or the squared prediction error, the actual weight was 200. 200 minus 190 squared. So that's going to be 200 minus 190 is 10. 10 squared is 100. So the squared residual for the third person is 100. So the total sum of squared errors, we will add these up, 0 plus 1600 plus 100, the total is 1700. So that's gives us an idea of how far off the predictions are using DIVA's equation. Okay, so Estilla thinks the best fitting equation is based for weight based on height, y hat equals 3 times x minus 50. Okay, so we have the same heights and same weights here. So for the first person, according to Estilla's equation, the predicted weight is 3 times 60 minus 50. 3 times 60 is 180, minus 50 is 130. And then the squared error, or the squared residual, the actual weight is 150 minus 130 is 20. 20 squared is 400. And then for the 70-inch person, Estilla's prediction is 3 times 70 minus 50. 3 times 70 is 210, minus 50 is 160. So the predicted weight using Estilla's equation for the second person, 160. Actual is 130. 130 minus 160 is negative 30. Negative 30 squared is 900. The third person, the predicted weight be 3 times 80 minus 50. 3 times 80 is 240. 240 minus 50 is 190. So the predicted weight for the 80-inch person is 190 pounds. The residual, 200 minus 190, and we want to square that. So 200 minus 190 is 10. 10 squared is 100. So if we add these up, 400 plus 900 plus 100 would be 1400. So the total squared error for Estilla is 1400. So if we compare the two results for Diva, the total sum of squared errors is 1700. For Estilla, it was 1400. So it looks like Estilla's equation gives us a more accurate prediction for this data set. So based on the SSC, it would be Estilla's equation would be more accurate. Estilla's equation is a better fit for this data set. Better fit, okay, based on the SSE. Okay, so that concludes this presentation.